Welcome to lesson 3 of the survey of mathematics. We're going to be talking about exponents in order of operations today. What is an exponent? An exponent simply determines how many times a single number is used as a factor in a problem. As an example, if we had 5 cubed, the 3 is the exponent, and it tells me how many times the base of 5 is used as a factor. In this particular case, the 5 is used as a factor 3 times. So we have 5 times 5 times 5, which is 125. If I have 2 to the 13th power, that means the base of 2 is used as a factor 13 times, which gives us a very, very large number. The number at the bottom is called the base. The number on the top right is called the exponent. So in the example of 5 cubed, the 5 is the base and the 3 is the exponent. In the case of 2 to the 13th, we had 2 as the base and 13 as the exponent. So what is the value of something like 6 to the 4th power? Well, that 4 indicates how many times the base of 6 is used as a factor. In this case, 4 times. So I need to multiply 6 times 6 times 6 times 6. 6 to the 4th power is 1296. Now, many calculators are capable of doing exponents. What you want to look for is either an x to the y or a y to the x. On a graphing calculator, you'll often see a caret key that looks like this. So if you have one of those calculators, the way you would enter this in on a calculator is you would first type in the base of 6, hit the caret key, or if your calculator uses an x to the y key, and then you type in the exponent, in this particular case of 4. And when you hit equals or enter, it should come up with a value of 1296. Let's try another one. Here we have 2 to the 6th power. This indicates that my base of 2 is used as a factor 6 times. So 2 times 2 times 2 times 2 times 2 times 2 gives me a value of 64. On a calculator, we would type in 2 to the 6th power, so 2 caret key 6, and that should give you 64 when you hit your enter key. Let's try 7 cubed. This tells me that the 7, the base, is used as a factor 3 times, which would be 7 times 7 times 7, which is 343. Some calculators do have a cube key. I very seldom use that because I get so used to using the x to the y or the caret key that I don't want to spend time searching for the cubed button. But many calculators do have them. 9 to the 5th. So my base of 9 is used as a factor 5 times. When you do that, you should get a very large number of 59,049. So that brings us to the next topic, that of order of operations. Many problems can be solved, but if you don't follow the same order, you may come up with a different answer than someone else who went in a different order. As an example, let's say we worked this one out. If we went straight through following every sign in the order that they come, we would end up getting an answer of 138. Let me show you. Here, if we take 4 plus 8 first, that would give me 12. 12 squared is 144. 144 divided by 2 is 72. Then we subtract 3, that gives me 69. And then I multiply by 2, that gives me a total of 138. However, 138 is not the correct answer. That is not the correct way of doing it. If I did the square first and then went in order, I would end up with 62 as my answer. Because I'd have 8 squared, which is 64. Then if I go 4 plus the 64, that gives me 68. If I divide by 2, that gives me 34. Subtracting 3, that gives me 31. And then multiplying by 2 gives me 62. However, 62 is not the correct answer either. We could go in several different orders and we could come up with a multiplicity of different answers. So which one's correct? Well, mathematicians have gone about creating guidelines, a step-by-step process that tells us what order we should go in. The first thing you need to do are all the symbols of inclusion. Usually that's a parentheses, but it could also include things like braces, brackets, the absolute value sign, or even the fraction bar, where you have several operations in the numerator that you have to do or several operations in the denominator that you have to do, but it's all in one fraction. Those would all be considered symbols of inclusion. You need to do those first. If there are multiple symbols of inclusion, you want to begin with the one that is in the innermost section and work your way outward. The second thing is you're going to evaluate all of the exponents, just like we did earlier in this lesson. The third step is to perform all the multiplication and the division in the order that they come. What that means is if I'm working through a problem and I have a multiplication problem and then another multiplication problem and then a division problem and then a multiplication problem, I do them in that order. I would do the multiplication, the first two multiplications, then the division, then the last multiplication. So however they form in the order of the problem is the way you're going to perform those operations. The same is going to be true with the last step, and that is the addition and subtraction, again in the order that they come. So if the subtraction came first and then addition and then another subtraction, that's the way you would do it. As an acronym to help you remember, please excuse my dear Aunt Sally is the one that I use. There are several others out there that you can probably find, but please, that stands for parentheses, but really understand that's any symbol of inclusion. Excuse is the exponents. My dear is multiplication and division in the order that they come. Aunt Sally is the addition and subtraction, once again, in the order that they come. So let's try one out. Let's say we have this example that I used earlier, but this time we're going to come up with the correct answer by following the proper order of operations. Do you remember what's first? The first step is to do all my symbols of inclusions, such as the parentheses. But there are none here. So I can skip that step and go straight to the second step, which is my exponent. My exponent is a 2 on the 8, so if I go 8 squared, that gives me 64. I personally like to see each step written out individually, so as we go through, we can see if you had a problem, where exactly you had the problem. So here I did my exponent. Do you remember what's next? Please excuse, my dear, multiplication and division in the order that they come. So if I look here, I've got 4 plus 64. Well, that's addition. I don't do that one first. The next step would be to do the 64 divided by 2. Well, 64 divided by 2 is 32. So I'm going to write that one out. So 4 plus 32 minus 3 times 2. But I need to keep on going because if I have more multiplication or division, I need to finish those up before I start doing the addition and subtraction. So this is addition, this is subtraction. Wait, here we have a multiplication portion. So I need to do the 3 times 2 next. 3 times 2 is 6. So I rewrite that. Now I'm done with all my multiplication and all my division. So my next step is to do all the addition and subtraction in the order that they come. So here I have 4 plus 32, that of course is 36, and then I can take 36 minus 6, and that gives me a final answer of 30. So the correct way and the correct answer of doing this particular problem, you should come up with an answer of 30. Let's try a few more examples. I'll give you a moment to do this one. We'll start off small and grow as we go along. So here I have negative 42 divided by 6 plus 7. There are no symbols of inclusion, so I can skip that step. There are no exponents, so I can skip that step. That brings me to the multiplication and division in the order that they come. In this case, I only have one portion of that, which is the division. But be careful, we learned yesterday that when you divide sign numbers, if they have the same sign, you're going to have a positive value. If they have different signs, such as what we have here, a negative 42 divided by a positive 6, we're going to have a negative value as our answer. So if I take negative 42 and I divide by 6, that should give me a negative 7. And now I have negative 7 plus 7. That's the only operation left. Negative 7 plus 7 is 0. So if you got 0 as your answer, you are indeed correct. Let's try one that's a little bit more difficult. 32 divided by the parentheses of 8 times 2. Here we do have a symbol of inclusion, that set of parentheses. So I need to start out with that. So I do the 8 times 2 first. 8 times 2 is 16, and now I can do the only operation I have left, which is 32 divided by 16, which gives me 2 as my answer. Alright, so let's try this one. Significantly longer, but do not get scared. Just do one step at a time. Now you will notice with this particular problem that there are multiple symbols of inclusion. We have a set of parentheses here, we have a bracket here, and then a set of parentheses inside that bracket. Well, the first thing I need to do is the innermost set of parentheses. So there's one here, and there's one here, but there's also one inside this second piece here, the symbol of inclusion of the bracket. So I need to do this portion first, the negative 4 times 9. Well, negative 4 times 9 is a negative 36. Now, to save myself a little bit of time, since this symbol of inclusion was by itself and was not recessed in anything else, I can also do that one in the same step. So there are some ways to kind of combine steps. Just be careful. If in doubt, don't do it. Just do one step at a time. But here I did do both sets of parentheses simultaneously. So the 96 minus the 70 giving me 26, and the negative 4 times 9 giving me negative 36. Remember, when we multiply two numbers with opposite signs, their answer is going to be negative. Now, this symbol of inclusion, there's nothing left inside of it. I could technically remove those parentheses, but you got to be careful in doing that if there's numbers outside. Here, I've got this symbol of inclusion of the bracket, so I need to follow order of operations within that bracket. So there are no exponents, but there is division. So I need to do the division before I can do the subtraction. If you don't, that is going to throw off your answer. So I do the negative 32 divided by 8, which gives me a negative 4. I went ahead and dropped the parentheses here on that 26 since it doesn't really affect anything. So now I have 26 plus my bracket of negative 36 minus 4. Well, I still have this symbol of inclusion. I need to finish that up before I do anything else. So I have to take the negative 36, subtract 4 from that, and that gives me an answer of negative 40. If you can't do that in your head, just think about I have a negative 36 plus a negative 4 and use your addition rules in order to solve it. You get negative 40. And now I have 26 plus a negative 40. I'm adding two numbers with different signs, so I find the difference of their absolute values, which is 14, and then use whatever sign is in front of the greater absolute value, that negative 40. So my final answer is going to be a negative 14. Here we have another one, significantly longer. I'll give you a moment to try this one. Go ahead and pause the video if you need to, work it out, and I'll be back and we'll get the solution. So with this particular problem, we have several symbols of inclusion. We've got exponents, addition, subtraction, all sorts of stuff. So what I need to do first is to work out the innermost set of symbol of inclusion first. So I've got a brace here. Inside the brace, I've got a bracket. Inside the bracket, I've got a set of parentheses. So that is what I need to do first. That 8 minus 6 piece becomes a 2. Then, now that I've got done with everything inside that symbol of inclusion, I start working my way out. So now I need to do the bracket portion. Well, inside the bracket, I've got an exponent. That needs to be done next. So within your symbol of inclusion, you're going to continue following order of operations. So I need to do my exponent first. 9 squared, 9 times 9 is 81. So that gives me 81 there. Now everything else inside that bracket is addition. So I need to follow order of operations just by going through and doing each one sequentially. So I have 25 plus the 81, that gives me 106, and then I add 2 more, that gives me 108. Now I finished up the bracket, so I work my way outward, and now I have to get my symbol of inclusion, that is the brace. So inside the brace here, I've got negative 16 plus 5 times this 108. I have to do the multiplication next. 5 times 108 is 540. So I have 32 minus the negative 16 plus 540. I still have the symbol of inclusion, so I need to take the negative 16 and add 540 to it. We're adding two numbers with different signs, so we find the difference in their absolute value. That's going to give me 524, and it is going to be positive because I have more positives than I do negatives. So that gives me 32 minus 524. When I do that subtraction, I get a negative 492. So good job if you got negative 492. If you didn't get negative 492, look at where you made your error. If you write out step by step each process, yours should look exactly like what I have up here. If it's different, know where you went wrong so that you can correct it in the future. Here we have 2 times the quantity, negative 5 minus 6 times the quantity, 3 squared minus 7 times the 4 plus 1. Now once again, I have several symbols of inclusion. I need to start with the innermost symbol of inclusion, which is this 4 plus 1. Even though it's on the end, it is recessed in other symbols of inclusion the most. So that's where I'm going to start. Of course, 4 plus 1 is 5. Now I need to work out my bracket. So inside my bracket, I do have exponents, so I need to start with that. So that 3 squared becomes 9. Then I do all the multiplication and division inside my bracket. This is subtraction, but this next piece here, 7 times 5, that is multiplication. It's actually a negative 7 times 5, which gives me a negative 35. Now I still need to finish up what's inside that bracket, so I have 9 minus 35, that gives me negative 26. Now I'm done with that bracket, so I move out to my brace. Here I have a negative 5 minus 6 times a negative 26. So I need to start out with this multiplication first. I have a negative times a negative, that's going to give me a positive, and 26 times 6 gives me 156. Now I have a negative 5 plus 156, that gives me 151 inside my brace, and then I need to finish off by multiplying outside by the 2, and that gives me a total of 302. So if you got 302 as your answer, you did it correctly. If not, look at your work. It should look exactly as mine does up here, and you can find out where you made your error. So as we finish up this lesson, remember, exponents are at the top right of a number. It is behind the base. The base indicates what you are using as a factor. The exponent, how many times you're using that number as a factor. And then with order of operations, don't forget to please excuse my dear Aunt Sally. Start off with all your parentheses and other symbols of inclusion, then followed by your exponents, then do your multiplication and division in the order that they come, and then your addition and subtraction at the end in the order that they come.